Bruce deposits 100 into a bank account. His account is credited interest at an annual nominal rate of interest of 4% convertible semi-annually. At the same time, Peter deposits 100 into a separate account. Peter's account is credited interest at an annual force of interest of, as given. After 7.25 years, the value of each account is the same. Calculate the force of interest. So nominal means in name only. So for Bruce, we have the accumulated value at after 7.25 years is 100. Now it's going to be 1 plus point. I'll write it like this: 1 plus 0.04. It's 2 periods because it's semi-annually, and then 7.25 times 2 because there's that many half years, right? Okay, and then Peter's account is going to have 100 E to the 7.25 theta. If you remember the PERT formula, it's kind of like that, okay? PE rate, which is theta times time, okay? So these are going to be equal, so we can set them equal to each other. So 100, and we can just make it a little simpler, 1.02 to the 15th power. 14.5 power equals 100 e to the 7.25 theta. Okay, now these cancel out. Now I can directly solve from here, but I can make it a little bit simpler from here, because what I can do is I can take you'll see what I'm about to do. So I'm going to take this root of it, 1 over 7.25. Of course, that just makes it a little bit simpler. We're already ready to, just use a calculator now if we need to. So I get 1.002 squared equals e to the theta. And now it's pretty darn simple, right? We can just easily use a calculator to do it. So I'm going to switch sides here. E to the theta equals 1.0404. And now we can simply say theta ln E equals ln 1.0404, taking the natural log of both sides. Okay, so ln 1.0404. Okay, so then I get the force of interest is 0.0396. Okay, so we choose C. Just to be clear, what I did over here was I took the natural log of both sides. Okay, and then the theta rules of logs, properties of logarithms, I can take it out, right? And ln of E is 1. So I just get that, okay?